Hello, today we want to go through some question about latent heat. Firstly, we go through definition of latent heat, and after that we start solving some problems. So latent heat is the energy added to a system during a phase change. For example, sometimes you have a solid, and if you want to convert this solid to liquid, you need to give some heat to that. This heat we name a latent heat. Then we have a specific latent heat of fusion. That is the amount of heat required to change the state of 1 kilogram of a substance from its solid state to liquid. So if you want to change a substance from solid to liquid, you need to give certain amount of heat to that. And if you want to convert liquid to solid, you remove the same amount of heat of the system. So for changing from solid to liquid, you need to give heat, you need to add heat. For changing liquid to solid, just you need to remove the same amount of heat from the system. And a specific latent heat of vaporization, same as heat of fusion, but in this case is the amount of heat needed to change the state of 1 kilogram of liquid to a gas. So for one substance is changing from its liquid state to gaseous state. And the formula that we use for calculation the amount of heat required is Q is the amount of heat required equal mass of the substance times L. L is a specific latent heat. So if you want to convert a solid to a liquid, here you put the mass in kilogram, definitely Q is in joule, and then you need to put a specific latent heat of fusion here. If you convert liquid to a gas, then you use same formula, just here for L you put a specific latent heat of vaporization. Right now let's go through some questions together. Okay, calculate the amount of heat needed to change 5 kilogram of ice. Okay, we have 5 kilogram of ice with a temperature of minus 10 degrees Celsius. And we want to convert this one to 5 kilogram of liquid water with a temperature of 10 degrees centigrade. Firstly, we need to see what's happening here. We have ice, and its temperature is minus 10 degrees Celsius. And we want to convert this one to water, liquid water, with temperature of 10 degrees centigrade. Okay, firstly, let's see what's something that we need to know to answer this question is melting point of ice. Melting point of ice is 0 degrees Celsius. So it means when you have ice minus 10 degrees Celsius, first you need to heat the ice to increase its temperature. So you need to heat it to increase to its temperature to 0 degrees centigrade. Okay, so to increase temperature, and you need to give heat. I name this heat Q1. After that, you have ice at 0 degrees Celsius, and you know melting point of ice is 0 degrees centigrade. It means at this point, we have a change of state. It means ice is changed to liquid water. So we have ice to water here. But we don't have any change of temperature. So still this water is 0 degree Celsius. The only thing that's happening here is change of state, no change of temperature. So it means delta T, change of temperature, actually is equal 0. But we need to give some heat here. Why we need this heat? Because we need some heat to break the bonds in ice to change it to liquid. After that, you have the water at temperature of 0 degrees centigrade, and you want to increase its temperature to 10 degrees Celsius. Again, we have a change of temperature here. So we want to increase T of water. Definitely, we need to give some heat. So altogether, the total amount of heat that we need to give is Q1 plus Q2 plus Q3. So I write Q total equal Q1 plus Q2 and plus Q3. But let's see what's Q1, Q2, and Q3 equal to. So I write it here, Q. Q1, because it's ice, and just we want to increase the temperature of ice. There is no change of phase here. Ice to ice with different temperature. So we need to use formula of mc delta T. So this is m ice, C ice times delta T for ice. Yes? That's better to just, I write it Q1. And Q2, actually we have a change of phase. We don't have any change of temperature, ice to water. So the formula that we need to use ml. And because it's melting, it's fusion, so L that we need to use is mlf. And Q3, again, we have water that we want to increase its temperature. There is no phase change. So it becomes M water. I write it here. Definitely C water because we want to increase the temperature of water times delta T. Right now, the only things that we need to do, substituting numbers. So Q total equal Q1, that is M of ice that we see in the question is 5 kilogram. C of ice that here we have it in the question, 2,100, so I times it here. Change of temperature, we know delta T always is T2 minus T1, or we can say T final minus T initial. And for ice, we see this one is T1 and this one is our T2. So it's 0 minus 10. Okay, this part is our Q1 plus. We want to do our Q2. Again, mass in kilogram, that mass hasn't changed, so it still is 5 kilogram. LF, specific latent heat for water is 3.34 times 10 to the power of 5 joule per kilogram. Plus Q3 is for water. We don't have any change in mass, so it still is 5. C of water is 86. And delta T is final temperature of water. That should be, this one is T2, T final for water, and this one is, it's T1. So it means it's 10 minus 0. Okay. Right now, just we need to do calculation to just find our Q. So Q equal by times this, it becomes 10, 500, 0, negative in negative is positive, plus 10, plus 16.7 times 10 to the power of 5 plus 930, 10 minus 0. That is equal to plus 16.7 times 10 to the power of 5 plus that is equal to because if you look at all of this, all unit of energy in our data is joule, here joule and joule. So here the unit is joule. Because this number is really big, we can just divide it by 1000 to convert it to kilojoule, but we don't have to. So if we divide it by 1000, it becomes 84.3 kilojoule. Okay, I hope it helped, but if you like, you can answer this question and put your answer in the comment section below, and then I check the answer for you. Have a great day. Bye for now.